everyone. So we start talking about statistics. What is statistics? Statistics is a branch of math it includes some steps. The very first step is to collect data related to the question that we asked. So step one, collecting data. After collecting data, we move on to step two, to visualize the data. Okay, after we visualize the data, is it normal? Is it skewed to the left, to the right? We're interested in assigning numbers, numerical characteristics, values to our data. So, analyze the data. So these are part of descriptive statistics. The last step, which is more important than the rest of these, is making conclusions, making inferences about the population. Make conclusion. This part is inferential statistics, making inferences. We start talking about data. Remember that we classify data in this class into two classifications. The first one is numerical. Another name for numerical, quantitative. Like height, weight, GPA, scores. Also, categorical data. Or qualitative. It's related to the quality. Qualitative. Like hair color, eye color, blood type, social security number, postal codes, and so on. Very well. Example. Suppose you have some cities and you have population of those cities. How do you classify these two data? We have some cities and we have the populations. Which one is numerical? Which one is categorical? Remember that when we are talking about numerical data type, you're interested in doing algebra. For example, finding the average. If the average is meaningful, you say that, hey, we have numerical or quantitative data type. So, very well. When it comes to cities, we have the name of the cities. It's not possible to add the name of the cities and say, hey, we have some numbers, we can do algebra. Of course not. So this is categorical. We can put cities in some categories. Categorical or qualitative. So what do you think about population? So when it comes to population of each city, of course, those are numbers. You can actually take those numbers, add them together, find the average, and that average is meaningful, of course. So this is an example of numerical data or quantitative data. numerical or quantitative studies. Very well. So in statistics, they have two types of study. As a statistician, you need to decide which type of study you're going to conduct. We have two types of study. The very first type is called observational study. So, observational study. As you can see, it's related to observing and recording the data. We don't make any changes to the applicant or to the data itself. We just observe and record. The second one is called experimental study. Like, you want to know what's the effect of a new drug on patients. How many percentage a vaccine is effective? These are examples of experimental study. You do experiment, it takes time. You need to check the stages before using the drug and after using the drug. Before conducting the exercise, after conducting the exercise. So examples of observational study, like conducting a survey. Asking questions. Answering questions on websites. We don't do any experiments. We just observe and record. However, for experimental study, we have to have some people and we're going to run some experiments. For example, you would like to know what's the effect of a drug on some patients. Or vaccine, or so on patients. You would like to know what's the heartbeat rate before exercise, after exercise. You're doing some experiments. So in this example, we have one, researchers studied the effect of vitamin D3 supplementation among patients with antibody deficiency or frequent respiratory tract infections. So we have some patients. To perform the study, 70 patients received 4,000 IU of vitamin D3 daily for 1 year. Another group of 70 patients received a placebo daily for 1 year. In your view, is this an observational study or is this an experimental study? So this is an example of experimental study. You're doing some experiments. There is a treatment, a new drug, vaccine, a new treatment. It takes time. You have some patients, they have some condition before using the treatment. They have some other conditions. Hopefully they get better after the treatment. So you're examining two different conditions before the treatment, after the treatment. So this is an example of experimental study. Vitamin D3. So you have some measurement, you have a treatment. These are all related to doing some experiments. It says researchers conduct a study to find that US public approval rating of US president. To perform the study, researchers called 1,500 US residents and asked them whether they approve or disapprove of the job being done by the president. What do you think? Is this an observational study or is this experimental? This is an example of observational study. Remember that. Survey, asking questions, answering questions, in general, collecting data without influencing people or participants is observational study. The president approval rate. You're just asking around, collecting the data. There is no treatment involved, just asking and recording. That's all. Example of observational study. So now we're going to talk about how do we collect the data and which method is the best method of collecting the data. How to collect data and what is the best method. Again, you are the statistician. Your job is to collect the data at random. You're forming a sample. Definitely a random sample. Randomness is very important. It must be random. You cannot say that, hey, I want to collect the data and I'm going to just ask my classmates. Convenience is no. You cannot say that, hey, I want to just ask my family members. That's no. You cannot have biased sample. You need to have a random sample. When you collect sample, you do some analysis on your sample. This analysis gives you some numerical characteristics. Numerical characteristic, like effectiveness of a vaccine. Then your company give the result to the population. They say, hey, these results can be applied to almost anyone in the population. So this is huge. Population. So it is super important for you to collect the data at random. So in statistics, we have different methods of collecting data. Let's go over one example to see what options do we have. In this example, we have, suppose our college is thinking of ways to raise money. Many students like parking spaces close to their classes. The administration is thinking of selling reserved parking spaces for $100. The college wants to know the percentage of students who would support this fee. Read the following ways to sample students at our college. For each method, tell whether the method would produce a sample that represents the student population. And second of all, if the sample would not be representative of the population. Explain why. A, this is the first method, choose for 8 a.m. classes at random, survey all students in each class. B, put a poll on the front page of the college website. A poll is an opinion survey. Use the students who answer the question at the sample. And finally, talk to students as they enter the student center. Which one is the representative of the population in our college? And which one is not? So if you selected 4 classes at 8 a.m., what's wrong with this? 4 classes at 8 a.m. You include everyone in this survey? Unfortunately not. You're just focusing on specific group, the group that has morning class. Of course, they're interested in having reserved parking. Of course, the result is going to be pretty high. So this is not good. Why? What's the reason behind it? Not everyone has class in the morning. So you are actually excluding people who have classes in the afternoon. What about those students? We exclude students who has classes in the evening or afternoon. Remember vaccines, just focusing on healthy people or people in a specific age group result in a vaccine not to be effective for the whole population. So if you just focus on students who are taking classes in the morning, you're excluding students who are taking classes in the evening that term. They might have classes in the morning next term. So this is not good. The second method was using college website and use the result of polling there. College website. Is this a good way? Well, actually, it's not a good method. Why is that? First of all, not everyone check the website every day. You might not even check the website for 1 week. I don't check the website for 1 week. I sometimes skip that and go directly to my website or go directly to my Canvas page. So again, you're excluding students who are not checking the college website. We exclude other students who are not checking the website. In this case, we say that we have voluntary response, which is not good. So let me write it here. We have voluntary response. Which is not good. As a statistician, your job is to find your sample, your random sample, and ask question or run the experiment. You don't expect people to self-select themselves and answer the questions. So voluntary response is not a good thing. What about the next one? The next one was talk to students as they enter the student center. Is this a good method? Actually, it's convenient for you to go to the student center, just stand there and ask questions. It's convenient for me, so it's not good. Not everyone goes to student center. You might just go to your class and get back to the dorm or get back to your job. Never had the chance to go to student center. So we exclude other students. This is an example of convenient sampling, which is convenient. It's easier for me to go there and stand there, ask question. No one knows. But it results in a not effective data numerical characteristic. So if I just generalize that information to the college population, it's not going to be effective. So convenience sample, which is not good. So what's the best way? So the best way is going to be just walking around the campus and asking questions. Now I expect you to ask, what about this situation that we have right now? We don't have access to campus. How do we collect data that are actually not biased and they are random?